G'day and welcome to another one of my videos. Today we're going to have a look at how we find the perimeter of a figure when there's a side missing. So we'll start off with the definition that I like, and that is the perimeter of a figure is the total length of the boundaries, not the distance around the outside, but the total length of the boundaries. So we add up all the boundaries. So that's just a quick review, and I went over that in my previous video. So, what if some of the sides are missing? Well, we need to find the missing sides first. So for some figures, that will be quite easy. So for instance, I've got a rectangle here. Well, it could be a parallelogram because I haven't said whether this angle in here is 90 degrees. But you'll notice that I've got markings on some of the sides. So whenever this is the case, that ends up being quite easy. So this marking is the same as that one. So this side must be the same as that side. And this has two markings on it, and I've got the same markings here. So these two sides are the same. So if this is 15, then also that is 15. So we need to make sure that we're looking for those markings regardless of how easy or complicated the figure ends up being. So once we've got those markings, we can then just put on those sides the correct lengths, so 6 meters and 15 meters. And then the process is still the same. So we just find the total of all the boundaries. And so, as I said, I like to start at a vertex and work my way around and add them up as we go along, which I've got there. That way we don't miss any of the sides, and we get a perimeter of 42 meters. Remember, there are some shapes that we can do some shortcuts with. So for a rectangle, we could have gone 2 lots of 6 plus 2 lots of 15. Or add the 6 and 15 first and then multiply by 2. So just remember, with some figures there are some shortcuts. So let's get into some examples. So we'll start off with what looks like a square. Could be a rhombus. Again, I haven't said whether this is 90 degrees or not, but that doesn't really matter when we're finding its perimeter. So we've got markings there. We want to find the missing sides. So we'll put in that each of these have the same markings, so they all must be the same as this one, which is all 9 millimeters. And we now need to find the total of the boundaries by working our way along the side. So starting at a vertex and working our way along and making sure we don't miss any of the sides, and we get that that's 36 millimeters. Again, we could have done a shortcut. We could have realized that there's 4 lots of 9 millimeters, and we end up with the 36 millimeters as well. So here's a second example. Let's find the perimeter of the kite below. Now they've actually told us this time that it's a kite. They haven't put any markings on there, so we need to think about what is a kite. So let's find the missing sides knowing that this is a kite. Well, the definition of a kite was to have 2 pairs of adjacent sides equal. So we've got a pair of adjacent sides here. So if this is 3, this is 3. And we have another pair of adjacent sides here. This one's 9 and this one's 9. So although they didn't again have the markings there to say this one's the same as that one, they did tell us that it was a kite. And we have to remember what our properties of a kite are to help us. So we've put our missing sides in. Now let's find the total of the boundaries by working our way along. Again, I like to start at a vertex and work my way around. So if I start at this one, I'll go 3 centimeters plus 9 centimeters plus 9 centimeters plus 3 centimeters. And that way, again, I don't miss any of the sides. And we get 24 centimeters. Again, we could have done a shortcut, 2 lots of 3 and 2 lots of 9. Or 3 plus 9 and then double it. Okay, so there's more than one way, but make sure we show our working so that your teacher or whoever's marking it can see what you're trying to do, just in case you make a mistake, and then we can find where those mistakes are and rectify that. So let's look at a third example. Let's find the perimeter of this figure. Now we start to get a little bit more complicated. We've got a missing side here and a missing side there. So again, we still want to find the missing sides first. Now the height here, it's the same as adding this part and then this part. So 7 and the extra 5 gives us those 12 meters in height. So then it ends up being a fairly simple one that we can find. So looking for things that are equal, and we can assume that these are right angles in here for these type of diagrams. Now we want to find this missing side here, knowing that this is 10 meters all the way along here, but part of it is 3 meters. So this part across here, so up until about here, is 3 meters. We want to find this extra bit that gives us 10 meters in total. So this time, to find this horizontal part here, we can do 10 meters minus our 3 meters, and that gives us our 7 meters there. So we now have all of our missing sides. And again, as I said, I like to start at a vertex and work my way around. So we'll start at this vertex here and work my way around. 3 plus 5 plus 7 plus 7 plus 10 plus 12. Now, another good reason why starting at a vertex is useful, because if I went 3 plus 5 and then went across here and realized that there was no side there, then I'd have to go back and calculate that just in case I had missed it in the first place. And there we have our perimeter there. But I can actually tell you that there is a shortcut for this type of figure. You notice that that's 10 meters, and these two together will make 10 meters. So I'll have two lots of 10 meters. And this is 12 meters, and these vertical ones together will also make 12 meters. So I'll have two lots of 12 meters there as well. So I could have gone two lots of 10 and two lots of 12, or do my 10 plus 12 first and then double it. So there are some shortcuts for some figures, but you just have to be careful because some people like to do them for all of them, and this next one is slightly different. So again, finding missing sides first. You'll notice there are some markings there, meaning this side, and this side are all the same. Now they're all the horizontal parts, and they all make up the 12 meters there. So the other thing too is we can assume, even though that there's no markings there, that this vertical height is still the same. So we get 8 meters, and we've got this vertical height here being the same as this one here, so put in 1 meter. So I'll do some obvious ones first. This next one we've got to do a bit of a calculation for though. As I said, 3 markings, so they're 3 equal parts. So we've divided this whole length across here into 3 equal parts, and we know that the whole length across is 12 meters. So if we just divide that 12 into 3 equal parts, we find that each of them are 4 meters. So now that we have all the sides, again, I like to work my way around, so I'll start at this vertex and 8 plus 4 plus 1 plus 4 plus 1 plus 4 plus 8 plus 12, and that way I'll put them all down, and then I can calculate the perimeter being 42 meters. So just being careful that we get all the sides, and we look for some little bits along the way. So I couldn't have gone just 8 plus 12 and then double it, because then I've got these extra bits in here. So you've just got to be careful with trying to do shortcuts all of the time. Okay, so what you now need to do is you need to practice, and then practice some more, and then practice again, and the more that you do that, you'll become familiar with those different types of shapes and what you need to look for to find those missing sides. So I hope you found this video useful. So get in there, have a go, and make sure you show you're working out and find those missing sides.